Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to work over on the steam Stoker engine, and we're working on making our cylinder sleeves that will be used for the valves on the Stoker engine. I've already kind of started this project. We ran into a roadblock in the first video where I was needing to be able to bore this out using a boring bar over here on my bigger lathe. At the time that I was shooting that video, I did not have the steady rest where I could use it. This was actually broken. So I actually took the time, we fixed the steady rest. That's already been posted in a video that you guys, if you watch regularly, have already seen me doing the repair work on the steady rest. We are ready now to kind of get back in here, and we're going to work on getting these cylinder sleeves bored out to size, and then once we get them to bore to the internal diameter, I'm going to put them on a expanding mandrel, turning between centers. We'll go back over to the lathe and we'll turn the OD. And again, right now, I'm turning both this internal diameter as well as the outside diameter a little bit larger on the outside and smaller on the inside than what the final is going to be, because we've got to do some porting. I want to do the porting, and once the porting is done, we'll actually take them to the final size and get things finished up. But for today, let's pick up where we left off, and we're going to get back over here on the big Monarch lathe, get this thing bored out, and try to get this job finished up where I can get these cylinder sleeves sent out to be ported, which, by the way, spoiler alert, I've already talked to a friend of mine that's got some CNC equipment. He's going to do the porting job for me rather than me having to do it manually. And that'll also give me some time to kind of get ahead on the next step on the Stoker engine project so we can really get this project moving along and across the finish line. So let's get in here and finish this job up. I've got my sleeve. We've taken it off the other lathe. I've got it over here. It's in the four-jaw chuck right now. I need to get this dialed in using a dial indicator. I just stuck it in here, so it's running out right now. I did put the bull nose up on this end just to kind of roughly get it centered up. And we will, once we get this end tightened up, I will put the steady rest, go ahead and get it running where it's running fairly true. So let's four-jaw this thing in and get it running true, and then we will move on and see if we can get this thing bored out with a bigger boring bar and a little bit more stable platform than the smaller lathe on this big bore. Like I said, I just threw this thing in here, and you can see, we're running about 85 thousandths out right now. So when I'm doing this, what I usually look for is, okay, I'll look and see where's my highest point or coming toward me. And I kind of adjust this with my jaws running either basically straight to me, straight up and down. So it's kind of on a quarter system here because that's where I can make my adjustment. So right now, this is coming to me. I need to go away from me. So what I'm going to do is I'm going to actually just walk around to the other side of the lathe. This thing needs to go about 85 thousandths. I need to move my needle half of that amount to get it where it needs to be. So I'm going to make an adjustment. I'm going to come around to the back of the lathe. I'm going to loosen up the jaw back here. Come back over here and tighten this one up. That's going to move it in. And we got about 20 thousandths. So that's going to help. So let me go find again my high point, which is pretty much right where we were. And let's see. So I'm going to put my zero here where I can kind of see it. I'm going to come around to this one. So we got about 35 thousandths. So there, go 180. I need to do about half of that amount. Again, we will just loosen this one up. And we'll try to squeeze out about half of that, which we didn't quite yet. So now let's find our new high point. I think our new high point is going to be on the other jaw now, right here. So let me go back around the other side, 180. So that's about zero there as well. So let me take about half of that out. Roughly right there. Let's find our high spot again. So now you can see we're only about 15 thousandths Total run out. There's my high. We'll go 180 to that, which is right there. I'm going to move my 0 around. I'm going to go ahead while I got it on this side and just loosen that up a little bit. We'll go to the other side, half of that. And there's a little bit of a bounce in there that we're probably not going to be able to turn out. But again, this outside is going to be turned later. I mean, we're honestly within 5 thousandths right now. It's probably good enough. But the perfectionist in me wants to try to make it a little bit better. So I'm just going to tighten up my jaws a little bit more. See if I can bump it out a little bit more. And we're just going to roll with that. Again, this doesn't have to be perfect at this point. I just want to get it close. We'll turn the outside diameter to match the inside diameter. But that's good enough. All right, now I got the bull nose in here. I'm just going to bring my jaws all down to where they're just touching. I'm going to back the bull nose out of the way here. We're going to have to bore this, so I can't have that on there, but the steady rest will support it. I was just using that to kind of get it roughly aligned. We've got the boring bar mounted in here. I've got an 1.5 inch boring bar in here, a little bit bigger, beefier than the one we had on the other lathe. I'm hoping this one's going to get the job done. I do have a 2-inch boring bar that I can fit on this lathe, but I'm going to have to bore it out a little bit before it'll fit. It won't quite fit right yet. But I think we are set up now. I'm going to give this thing a try, and hopefully we're going to be able to get the job done over here using this boring bar on this lathe with the steady rest. This is just a little bit beefier setup, and hopefully we can get in there without where it's not flexing too bad and get this thing knocked out. Let's give it a try and see what happens. All right, I got my machine running at about 255 RPMs. We got about 10 thousandths per revolution feed rate. I'm going to come in here. I'm just going to start there where it's touching off. I'm going to make a little light pass through here and see how it goes. I can see some flex in the boring bar, but as long as it's sticking out, I'm not surprised. Let's see if we can get a good cut through here. And just once I get a uniform cut going on, it won't be as big of a deal. It'll be flexing, but it'll be pretty much a constant flex throughout, so you'll end up with a good bore. This is why when you're boring, you need to, when you get close to the end, start making cuts without moving your cutter at all, because you do have flex in there, and it's just the nature of the beast. The more rigid you can get, the better. I'm not crazy about it, but it is what it is. Let's see if we can get it to work. Guys, just getting a little quick update. I've made 2 passes. This is my 3rd pass. I'm still doing pretty light cuts, about a 20,000th step of cut. I'm just trying to get out of that interrupted cut phase that we're in. Things seem to be going pretty well. Yes, we're getting a little bit of flex in the bar, but I've actually got my speed up. We started at 255 RPMs. I went to 295. I'm on 330 RPMs now. It seems to be cutting just fine. I'm just kind of easing it up a little bit, trying to find that sweet spot. Once I get a cut that's not interrupted, I think I can probably increase my depth of cut a little bit, but right now I'm just kind of easing into this because I don't want to put too much stress on that insert going from the shock of it hitting every time it goes around. But it seems to be boring pretty nice. I took a peek up in there on the last cut, and seems to be making a nice finish in there, so it looks promising. I think we're headed in the right direction. We'll bring you guys back. All right, I just took a peek up in there, and we are cleaned up from one end to the other. Let me see where I kind of ended up here. So that's 2.600, 20, 25, yeah. I took a 30,000ths cut, and that's pretty much exactly what I got there, within a thou of it. All right, here's what I'm gonna do. I'm gonna take a spring pass on this. When I say spring pass, we're gonna feed the cutter through without feeding it in. It's still gonna cut because of that flex that was in there, but that should give me a little bit truer of a cut. And we're gonna call this one good and move on from there. Like I said, we're gonna have to bore these out to the final dimensions in a later step. I just want to get a good smooth bore in there right now is my main goal. So let's see. Again, I'm not feeding in, we're just going to take a spring pass. And you can see it's still cutting. That's that flex that's in the boring bar, and it's got flex in there now. But each time you make these passes, it's a little bit less and less. And when you're doing that final bore, and again, you really only want to be taking a couple of thousandths per pass if you're trying to shoot for a real accurate bore. In this case, I'm not too worried about a super accurate dimension. I just want to get a good clean bore all the way down, consistent size from one end to the other. All right, there we go. Now on this last pass here, I don't want to drag my cutter back out, so I'm going to feed in a little bit so that it's not cutting coming out. I'm going to pull my boring bar out. Got a nice clean bore in there. And just for fun, let's see, so that's about where we were. That's 1, 2, 3, 4, 5. It's about 6.5 thou I cut there just on the spring pass. So again, that's just how much flex is in that bar. Not much you can do about it except get a stiffer setup, and with you got that long hangout, you got a lot of leverage going on to move things around. All right, I'm gonna get a cutter in here. I'm just gonna face the end of this off square. We've still got a rough casting there, and I think we'll be through on the lathe here with this part. I'll need to do the second one. And I got a regular cutter here, and we're just gonna feed in there, and we're just gonna face this off until it's nice and flush. Up my steady rest here. And we can pull our part out of the chuck. I'm just going to loosen up 2 of these jaws and try to leave it kind of set. The other one's probably not the same diameter, but we'll have to indicate it in. That'll work. All right, let me get the other one in here. It's in the chuck. We'll snug this up. I'll get my dial indicator out, and we'll get her going over here. Got both of these bored. They're close to the same diameter. Again, I'm not trying to hit any specific number. I just wanted to get a good clean bore through there. They're both below size like we talked about before. And now what I want to do is I want to actually turn the outside concentric to the inside. And to do that, we're going to put them over on one of these expanding mandrels. That is my game plan. So the way this works is you got this piece here. This is on a taper. When you slide this up on here, it makes this larger and larger and larger, and you can basically just make it to where it expands on the inside of what you're turning, and then you just put this over that, expand it out, and put this between centers, and you can turn your outside diameter to your inside diameter. So that's kind of my game plan here. Try to expand that out a little bit. And let's see, I think I want to go this way. All right, so we've got that expanded in there. I'm just going to take a brass punch here and kind of drive it home. And now, just from friction, when I put this between centers, it's going to turn that outside diameter. Let me go over there and get my lathe set up to turn between centers, and we'll get this set up and turn that OD to the diameter I want. And I've got my mandrel here, and I got my centers in. I always touch up my center on this end on the lathe because I just screw it up using the compound. I've got this now between centers. I've got a drive dog on this end. I got a live center on this end. I'm just going to tighten this all up. We'll lock that in place. Let me get my drive dog where it's engaging down there. Right now, this will just twist on there, and I want it to drive, so I've got this, what we call a drive dog, and this just tightens up on the shaft, and it's going to come over here and actually engage with the chuck. And as the chuck is spinning around, it will also spin the mandrel with it. So now, that's hitting right there. So as the chuck spins, so does the part. And again, this mandrel turning between centers should be nice and true. We're going to true up the outside of that now, and then that should make the two parts concentric with one another. Get a tool on here. Start turning this out. I'm going to touch off up here. Just let that cut across. Much better. Still kind of getting that outside layer off. I may slow it down just a little bit here on the next pass. All right, we're running at 546 RPMs, and my feed rate, let's see, BC is about 8.7 thou per rev. That seems to be cutting pretty good there. We'll just let it roll on through here. I'm doing a 60,000th total diameter reduction here. Just let it go on out to the end there. It's already kind of down to that diameter on that end. All right, just doing a little bit of checking here. Again, rough dimension here, 3.650 within 5 thou. Right now, what I want to do is just kind of get this roughly turned to a diameter that we can work with. The diameter that it needs to be in its final form is 3.250, actually about a half a thou larger than that. It'll be a press fit up into a hole, but again, for right now, I'm going to leave it a little bit oversized. I'm going to leave it about 100 thousandths oversized. We'll do our final outside diameter turning once we get this thing ported, all the holes put in it, and get the inside diameter completely finished to its final size. We'll come back and do this again and get it to that final dimension that we're after. So I'm going to be shooting for about 3.350. We're about 3.650, so I got about 300 thousandths to come off of it. I'm just going to put that in the digital readout, and I think I'm going to slow this down a little bit more. Not real happy with that finish that I'm getting. I think I'm just got a little bit too much surface speed. All right. Let's try that. All right, I put another tool in here, and this is cutting much better. I've already made one pass. We're about 2.48 right now, according to the digital readout. Again, going to 2.350 roughly for a rough diameter. We'll let it cut across, and again, this isn't the final diameter, but this is where I'm going to stop at today. So we'll finish cutting this one out, and we'll bring you guys back here in a minute. And the last thing I have to do is face this edge off to get it to the right length. I've already got this side was faced off over on the other lathe, but we do need to get this one down here on the other end, faced off from the rough casting to the proper length. I'm going to go check and see what that needs to be, and we'll get that done here in a minute. Just double check my measurement. Yeah, we're about a thou under, but again, no big deal at this point. We're just roughly getting it where it needs to be. All right, let me get something to measure off here. Got a set of 12-inch calipers here, and this needs to be 8.5 inches, and we're about 8.840 right now. So again, got a good bit of extra material in there. I got a little burr on this side. I'm going to knock that off just to make sure I'm not measuring across that burr. We're going to call that 8 inches, 835 thousandths. Put that in my digital readout. 8.835. I'm going to 8.500. My measurement hasn't changed on the digital readout. And we're about 5 or 50 thousandths still to take off. I'm at 852. Just a fuzz more. That should do it. Gonna go ahead and break that edge. And this sleeve is done. For now. So guys, we got the 2 sleeves machined inside and outside, and I fully intended to have gotten a little wrap-up shot there of the parts laid out, and lo and behold, I got in a hurry to get them boxed up and shipped out to California to get those things machined, to get the porting done in it, that I forgot to do it. And when I went in to edit the video, I realized I forgot to wrap the thing up. So I'm actually out here in the shop a day or 2 later, just doing a quick wrap up on this, but just letting you know what's going on. Yes, we did get everything machined out. Parts are again a little bit oversized. I've sent them out to Dragonfly Engineering out in California. Same guys that have helped me out with some other stuff on the Stoker engine project. He's going to use his CNC mill to actually do the ports in there. He's got a mill that basically can set it up where it'll rotate it and do all the porting instead of me trying to do it manually, and it's just going to be a lot easier to do that CNC. And like I mentioned before, that's going to kind of enable me to jump ahead and get some other machining done for this Stoker engine so that we can get this thing wrapped up and get this job finished up and out of here, because they're getting really, really, really close to needing it up in Nashville to wrap up that project that's been going on now for several years. So with that, that is a wrap. As always, thanks for watching. Please subscribe if you haven't already. Those thumbs up and comments are greatly appreciated. They really do help out a lot with the algorithms on YouTube. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships, all of which are great ways to support my channel or any other channel. Like I always say, if you feel like you're getting value out of these videos or really any other YouTube out there, consider contributing a little bit extra, even if it's only $1 or $2 a month. It really adds up and it really makes a difference, and it really does make a big difference in my shop. And guys, with that, we're going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.